All right, good morning. So we are going to finish up this one. This is going to be an amazing video. We're going to learn how to use the calculator a little bit on this one. So this is a continuation of our question here dealing with water flow. So we have a model of the amount of water in the tank is given by this equation. So in this case, this is the equation for our water in the amount of water in the tank. In the first example, it was given by W of t, where W of t was from our table. But this time they're giving us A of t at the A of t, which is the amount of water as an equation. And again, A of t is the amount of gallons in the water, and t is measured in hours. Now they're asking us to find A prime of 15. Now this is different. I don't need to use my average rate of change because I have an equation. So this right here is a direct derivative. In other words, now we're thinking instantaneous rate of change right here. So how do I find it? Very easy. On the calculator, this is what you're going to do. To get A prime of 15, you're going to write out A prime of 15. But this is what you're going to do on the calculator, homies. Turn the calculator on. I like to be in Scratchpad, easy to work with. You're going to go to Menu. Just go to Menu. After Menu, is there anything here that looks like might help you with calculus? Algebra? No. Oh yeah, number 4. So you're going to press number 4. Go down number 4. And we are looking for a derivative at a point. So I'm just going to go down to number 2 here. And I just press enter. And it's going to give me this, variable. Now I have a choice here. Your calculator can do parametrics. So you can keep the t if you want, or you can just leave it as x. I'm going to leave mine as x. All right. Next, I want to find the value where I want to find the derivative at. And in this case, it's 15. And here's a cool feature. What if I want to find, I can find more than just one derivative. I can find the first derivative, second derivative, nth derivative. We only want the first derivative, so we're okay. I press enter. Oh my gosh, look at that notation. That should look familiar. All you have to do now is just type in your equation exactly as it looks. 1 divided by 225 times, open up a parenthesis, negative, now remember, I used x and not t, negative x to the third plus 30 x squared plus 1800 x 33,750. All right, once I type all that in, press enter. And what do you get? 9. It just gives you the answer right away. And I know that this is going to, so it's going to be menu, calculus, right? We go menu, menu, calculus, and then number 2, derivative at a point. And then you're done. Escape it out of there. And I know the units. This is going to be, of course, gallons per hour. It's very easy to do. All right, now it says, use your calculator in the model given to find the average rate of change. So now they want A rock over the time. There's A and there's B. So to get our average rate of change, this is going to be of 20 minus A of 15. Oops, sorry, not A of 15. That's I can do this. One, I could just type it all into my calculator, or I could just graph it. Sometimes a little bit easier to do. 1 divided by 225 times negative x to the third plus 30 x squared plus 1800 x plus 33,750. Press enter. I want to find, press enter, there we go. It doesn't show me anything, but that's okay. I want to find these numbers up here. So on the calculator, what you're going to do, to get the value of on a calculator, you're going to go to menu. From menu, you want to go to trace. You want to go to trace. Number 5, trace. That's that number 5, trace. Press enter. And you want graph trace. You want to trace something on the graph. Now, so we're going to go to, come on, there we go. graph trace. That is number 1. Press enter. Now you don't have to highlight anything. You don't have to scroll. All you have to do is just type in the 20. Type in 20. Press type in 20, and it goes there. So it says A of 20 is 328. So if I go over here real quick, so I'm going to put that down. 328 minus, and I just press the number 4. I press enter, and it's going to give my value down there. That's at 184. I want that 184. That's my value. Oop, there should be a parenthesis there. Obviously, I like parentheses. And this becomes over 16. Simplify. Go to your home screen, homie. And we're going to get 328 minus 184. So I get 144 over 16. If I divide that by 16, we get, again, 9. Oh, that's interesting. And again, it's going to be gallons per hour. Oh, man. Take a look here. Look at these slopes. If you notice, they're the same. That is insane. Because remember, this is my instantaneous rate of change. Right? That's IROC. This is my average rate of change. And notice, over here, we have our instantaneous rate of change equals our average rate of change. This is what we call the mean value theorem. And it states that if a function is continuous and differentiable, then at some point your average speed has to equal your instantaneous speed. Like if my average speed of driving is, if my average speed of driving is 20 miles per hour, right? If my average is 20 miles per hour, at some point my speedometer also had to read 20 miles per hour. We are going to talk about this a lot in here. All right, hope you guys enjoyed the video. Like my channel. See you soon. Bye-bye.